All right, here we go. Boy, it's been a while. Now, 10 years later, here I am. Still using a chalkboard. Our technology is colored chalk, and guess what? Still gets the job done, still 10 years later. All right, so this video is going to be about gravity, but given the importance of math, right? Like, math is really important, and having a good foundation of math is really important. And we're continuing in the 8th grade center science department to find ways to build our physical science course by trying our best to emphasize math topics and simultaneously blend it with science, obviously with gravity in this case. And gravity is one big important component of the PSSA. So we've taught you in class about how gravity depends on mass and distance. We said, you know, the closer the objects are, same two masses, the closer they are, the more gravity. The farther apart they are, the less gravity. In our class, we do our meditation where we go G up, G down, G up, G down. Again, as the masses get closer together, gravity goes up. As the masses get farther apart, gravity goes down. We discussed why we stick to the Earth. That Earth has the biggest mass. That's all in class. Okay, but now let's apply this mathematically with a formula. We're going to use part of the formula. In challenge science, you guys know there's this capital G constant, 6.67 times 10 to the negative 11th, if I'm not mistaken. Let's not focus on that. Let's just focus on the basic idea of variables and how to manipulate them. Okay, so on this paper we got right here, we're going to start with gravity being 20 newtons. So my first box, I'm going to write down, remind myself, force of gravity. I know there's a capital G component. We're not worried about that right now. Let's keep it simple. Conceptual understanding with math is key. We're going to go m1, the one mass, times m2 divided by the distance between their centers squared. That's the general formula. Again, formulas make science easy. If you understand the math, you can understand the concept. So again, gravity depends on two masses and how far apart they are, squared. Okay. So I'm giving you a starting gravity. We're using a fake made-up number of 20 newtons. Okay? So what we're going to look at here in these problems is if I change one of these variables, or if I change both, or if I change all three, how will that mathematically impact that value? So we're going to look at the math of that. We're going to talk about order of operations, exponents, fractions, right? But then we're going to bring it back to, okay, well, if this went up and this went down, what happens? Like, we're going to get into that also, so it's really cool. Okay, so overall, we're starting with a gravity of 20 newtons. So we know that this is equal to that, okay? Force of gravity is this formula. Our starting value is this. This is that. So I'm going to keep this in yellow, and I'm going to write this over here in this box, 20. And I'm not going to put the unit, okay? And I'm going to put a little multiplication sign right here. Because now, if you take a look at number 1, I'm going to start easy. It says start with gravity being at 20. That is our m1 over m2, I'm sorry, m1 m2 divided by d squared. But now we're going to increase mass by a factor. Now we're thinking coefficient. Factor of 3, what is the new gravity? So to me, this is a simpler one. We're going to increase one of the masses, right? Keep the distance the same. So it's almost like, here's the two masses. There's the distance, right? What if I make this more massive? I don't know. Now it's more massive. Okay? So what do you think happens conceptually? More mass, same distance, more gravity. Okay, now let's mathematically prove it. Okay, so here's what we're going to do. So it says here we're going to increase mass by a factor of 3. So we're going to develop a coefficient here. So now we're going to be 3 times the original mass. So this tells me 3 times the original mass. Fraction, coefficient, over same distance. How do I put that? 0 means we're not changing it. Time out. Could I put that? What's 3 divided by 0? 3? 0? No, it's undefined. Right? Can't do that. So if we're keeping it the same, we're going to give it a coefficient of 1. And don't forget the exponent. You know sometimes I forget it. Squared. And so our original value of gravity is going to change due to the change in mass. the gravity's going to change. And predict again, mass goes up, gravity goes up. This is a direct relation, so hold on. So, but wait a minute, we have order of operations. Where do we go first? Exponent. What's 1 squared? 1 squared is the same as 1 times 1. So now I'm going to get rid of the exponent. Order of operations, hello, 3 over 1 times the original value of 20. Okay, you know 3 over 1 now is 3, right? Times 20. Our new value is 60 newtons as our new gravity. Conceptually, does that make sense? Well, if we increase the mass while keeping the same distance, more mass goes up, more gravity, 3 times 60 newtons, that's it. So that's an easy one. Again, the yellow, 20 newtons was this. Now we're changing the parameters, the variables. That's how we develop our coefficient. 3 times the mass, same distance. Now sometimes kids may put a 0 there. I understand why, because you're not doing anything to it. No, keep it as 1, but don't forget the squared, even though 1 squared is 1. Get rid of the exponent first. Then technically we're dividing, but we know 3 divided by 1 is 3. Now go across, times 20, 60 newtons is our new gravity. Okay? All right, now let's do a little more complicated one. I'm going to skip down to number 3. So I'm going to do 3 various different problems, okay? So let's take a look at, what did I say, 3. Again, we're going to start with gravity is 20. So again, I'm going to write my formula, because again, if we understand the formula, that helps us understand the concept. Again, math makes science, like physics and chemistry, easier. That's why we're making a big push on math skills to help us bridge the gap, to improve our math, which is so important for the high school, right? But also it helps us really understand the science concept. So now, then we have 20 newtons. Okay, so we know that's 20. Now let's see what we're changing. Let's keep the same old school technology, red and yellow chalk. There you go. All right, so now, let's start manipulating this. It says here, force of gravity. Let's start to do the math, some order of operations here. Now we know we got a 20. I'm going to put the 20 over here. That's a given, because that came from here. Okay? But now we're changing stuff. Oh boy. We're decreasing mass by a factor of 4 and increasing distance by a factor of 4. Okay, now. We're going to decrease mass. Let's look conceptually for a minute. This is going to, less mass, more distance. Think conceptually. Less mass, more distance. This value is going to be smaller for sure. So we're going to find the number less than 20. And you should know that. That you should know. Now we're going to help build your math skills to prove it. Okay, now let's see here. So it says here decrease mass by a factor of 4. So there's different ways kids go here, and I understand. I totally get it. Decrease by a factor of 4. We're doing a coefficient. So some people put -4. And I get it, but that's not what we're doing here. Our original gravity was like 1 whole. We're decreasing it by a factor of 4. That means our new mass is 1/4 the original value. 1/4 the original value. We're 1/4 before. So pretty much, if we had 100 for mass, and now it's decreased by a factor of 4, now our mass would be 25, not -100, okay? By a factor of 1/4, it's a fraction, all right? So but I understand why you put it. I've seen it. And that's why we're making this video, because we're starting to see little things, and we're actually, for real, ready for this, acting on it and trying to help kids. We see things and we address it immediately. All right, and make things better for down the road. Okay, so now, 1/4 the original gravity, I'm sorry, the original mass value. Now what about the distance? Okay, increase distance by a factor of 4. Okay, divide 4 times the original value, but don't forget, squared. All right, now, hold on a minute. I don't know if you've heard this term. This looks like something called a complex fraction. Okay, no problem, we can work with it. What? Relax. Again, order of operations. exponent first. So I'm really gonna draw this out, okay? So we can really get good. Exponent first. Don't get intimidated by this. Okay, now watch this. Bring it down. All right, bring it down. So now, here's step one, step two. We're gonna rewrite 1/4 divided by, what's 4 squared? It's 4 squared is not 4 times 2. No way. 4 squared means 4 times 4. Okay? So 4 squared is 16. All right. Times 20. Let me make sure you can see this. Hold on. One-man production show. Oh, let me zoom in on that a little bit. I'll write a little darker too. Okay? Here. I got it. No problem. We're flexible here. We try our best. There you go. All right? Here we go. So now, how do we simplify this? Okay, kids look at this like, oh my gosh, what is this? What? Okay, relax. I'm going to put this in a different way. We're going to keep this to the side. This is to the right. I see a lot of division right here. We got to attack this first. Order of operations, I see some division going on over here, and I see some multiplication going on. But we know that multiplication and division kind of get the same priority, you know? But what's the tiebreaker? These guys are to the left. So we're going to manipulate this guy first. So watch this. I'm going to bring this up. 1/4, rewrite it. 1/4, what's that mean? Divided by, what's that? 16 over 1 times 20. You know from way back when you can't divide fractions like that. You just can't leave it like that. So a previous teacher said this, and I think it sticks. It's really good. Keep, change, flip. That's that reciprocal thing. You know what I'm talking about? Times 20. All I did, 1/4 divided by 16 times 20. Maintain that left to right mentality for order of operations. Keep, change, flip, and then you still have this here. Now I'm going to bring it over here, okay? So I'm going to kind of, my next step is over here, okay? I'm just really drawing it out to help your math skills. So hold on. So now we're going to do 1/4 times 1/16. I'm just rewriting this so we can see it, times 20. So now you're left with, do this first, 1/64 times 20. So think for a minute. Just think, if you had a chance of winning something, your chances were 1 out of 64. Would that be a high number or a low number? Like a high percentage or like a low percentage kind of thing? I'll tell you right now, it'd be a low percentage kind of thing. Your chance of winning is 1 out of 64. So you're gonna have a small number right here, okay? But I want to maintain the fraction first. Let's use our idea of multiples and cross-reducing or canceling, I think they call it, right? So to simplify this out, 1/64 times 20. Is there a number where both 20 and 64 can be divided by? And the answer is 4. So I want to cancel this out. 4 goes into 20 5 times. 16 here, because 16 times 4, right? So you're left with, I'll put it down here, your new value, your new force of gravity is 5/16 of a Newton. Think about that for a minute. So we started with 20. And we said, wow, we're making the mass small and really pulling them apart. Okay, so gravity's going to go down. No doubt. We did all this stuff with the order of operations, exponent, divide, multiply with the reciprocal, left to right, simplify fractions. Well, that's a lot of stuff there, right? But wait a minute. Our new value, we started at 20. We went all the way down to 5/16. Well, what does 5/16 mean? What would 1 Newton be in this case? 16 out of 16. What would a half a Newton be, mathematically here? 8/16 or 1/2. We're left with 5/16. That's less than 1/2 of a Newton. So you can say, based on this data, decreasing that mass and really increasing that distance, we significantly reduced the gravity from 20 down to less than 1/2 of a Newton. Okay? All right, good. We'll do one more together. All right. Let me erase this. Turn the page, turn to the back page. We're new number 5. And I'm going to clean this off good. Let's do number 5. Hey, by the way, what you're seeing right here is your science review. Always learning, right? So you see the chalkboard's wet, right? There's water on this paper towel, right? Water. And, oh, we're good. Slow but sure, I gotta wait for the water to go away. So we gotta wait. So we're wasting time. No, we're not gonna make this a teachable moment because we always learn here. The water on the board, ask yourself, where's it going? Is it disappearing off the face of the earth? What's it doing? Think for a minute. You should know this. And then ask yourself, is this a chemical or physical change? And how does this correspond with law of conservation of mass? Okay, so what's happening is, I clean off the board. Actually, it'll look more messy in a minute, but whatever. That's how we roll here. We do more with less, and it's great. What happens here is the water is evaporating. And we knew that evaporation is liquid to gas only on the surface of a liquid. And since we have a very thin layer of water on the board, it'll evaporate quickly, right? And what's left behind is still some of that chalk residue. But where does the water go? Water's not just a liquid, it's also a gas. And when we said water, H2O, right, goes from a liquid to a gas, it evaporates. It's now water vapor in the atmosphere. And for you challenge science students, we already talked about before, because we're going to get to chemistry again soon. Remember how the liquid, the IMFs were still present, along with the positive end hydrogen and the negative end oxygen on that H2O molecule? But once there's enough energy at the surface to randomly escape, right, we know that these molecules now, their IMFs are non-existent, therefore they have enough energy to float in the room as gas, water vapor. So this was a physical change. Wow, great review. We don't waste any time here. Okay. All right, let's go to number 5. Back to this. Look at that, we just reviewed. What do we got here? Number 5, start with a gravity being 20 newtons. Yo, check this out. Increase one mass by a factor of 3. Oh, geez. And another mass by a factor of 2. And decrease distance by a factor of 5. Okay, hold up a second. Now the difference here is, dude, they're saying, like, look at, we're gonna mess with both these variables. So hold on. So let's just do arrows first. This is gonna get bigger. And this is gonna get smaller. So let's go back to G up, G down, right? Two masses, whoops, right? G up, closer together, more gravity. G down, further apart, less gravity. But now, dude, check this out. Part 1. Hold on. Oh, look at this. Increase one mass by a factor of 2. Look at that chalk. Look how valuable chalk is. Increase one mass by a factor of 3. Dude, we just added mass. And we're gonna what? Decrease distance by a factor of 5. Well, I don't know how to do that, but we're gonna bring them closer together. A lot more what now? Gravity. Okay? So again, one mass, two mass, right? We start here, there's gravity. Not that much, only 20 newtons, right? 20 newtons. We're going to increase one mass by 2. Increase one mass by a factor of 3. Put them closer together. We're going to have a lot more gravity than before. Let's see what happens. Okay, so now, so how do we simplify this? So ultimately, I'm going to start my formula over here. F of G, we know we have 20, so I'm going to put times 20. And again, I'm putting that multiplication over here. That's how we finish it off. We simplify the change, and whatever change occurs will impact our final number. So we're going to, with order of operations, all this division, exponents, all that's getting taken care of here. And then to the right, we're going to finish it off. All right, so watch this. So it's telling me increase one mass by a factor of 3. So I'm going to go factor of 3. 3 times the original mass of M1. The other one by a factor of 2 times 2. Hold on. Right? Decrease distance by a factor of 5. Now wait a minute. -5? No. We are now going to have a new distance 1/5 of what we started with. 1/5 of what we started with. So it's 1/5. What did I forget to do? And I did on purpose this time. Up. It's squared. Okay, so now we're going to simplify this. Okay? Write down a question if you have on this. All right. Order of operations. How do we simplify this complicated looking thing? It ain't complicated. Just watch. So we got f of g. Exponent first. Leave this alone. You know, you stay there. So we're going to go 3 times 2. Keep this guy here. What's 1/5 squared? It's the same as 1/5. I'm writing it small. I'll write it bigger in case you can't see it. 1/5 times 1/5. What's that? 1/25. 1/25. Okay? Times our original factor of 20. So now we've got, this is still there, but we did the exponent thing first. Okay? So now we can keep going. Let's keep breaking this up. So now, next step, we got 3 times 2 is 6 divided by 1/25 times 20. I'm going to bring it over there in a second. So now, we're still maintaining that concept of order of operations. And I'm going to tell you right now, order of operations is going to be huge in algebra, or honors geometry, or algebra. It doesn't go away. It really doesn't. Trust me, I know. All right, now watch this. Bring the hour up here. So bring the guy up here. So now let's simplify this. Let's make this understandable. So this means 6 divided by 1/25 times 20. So we know this is like dividing fractions. So we're going to go 6, keep, change, flip. I'll keep the 1 times 20. So again, look at this. Now we're left with, go back up here. You ready? I could have said, hey, let's do this. Let's cancel 20 and 25. And wait a minute. Why would that be wrong? I could say, hey guys, yo, this is like 5, this could be a 4, this could be a 5. No, we don't do that. That would violate order of operations. But people will say, well, division and multiplication get the same priority. Okay, but what if that's all you have? What's like the tiebreaker? Go left to right. Go left to right. Left to right if you're tied. It's like an overtime kind of thing. So we change this guy, right? Work this first, right? So now look what we have. It's both multiplication. What do we do? What's the tiebreaker? Left to right, done. So it becomes 6 times 25 times 20. So you get your 6 times 25 answer first, then multiply it by this, then multiply by 20. Dude, your new gravity? 3,000 newtons. We went from 20 to 3,000? Well, think for a minute. Think. You should think, if you understand the science and you do good with the math, it makes sense. Dude, we really increase the mass significantly. And you see that mass is directly related to gravity. Right? And not to mention, this is inverse. We decrease the distance squared. Does it make sense to have 3,000, something significantly larger than that? Absolutely. Okay, so right there we just reviewed a lot of math, but it goes back to this. Gravity depends on 2 factors, mass and distance. The bigger the mass is, the closer they are, the greater the gravity. The smaller the masses, the farther apart they are, the less the gravity. Again, it's G up. Again, when you bring them closer together, more gravity. G goes up, gravity goes up. G down, less gravity. Okay? And keep in mind too, gravity's everywhere. Weightless, right, means only gravity's acting on you. You're floating, free fall. We'll learn that in class. But again, gravity's everywhere. Don't ever say there's no gravity. Gravity's everywhere. Okay? All right. You do the rest of the problems, and we'll work on them in class together, and we'll talk about it in class. All right? Good job. Hope that helped.